when the webinar was organized, I was asked to give this presentation on, what we at the ICFR, what we've been doing with a drone, which was quite a new thing for us 2 years ago when we start. Considering that I am the first presenter, I also thought that it would be good to give an overview of the importance of unmanned aerial vehicles in forestry research. Just touching on some important aspects. So, UAVs, unmanned aerial vehicles with sensors are very important, are becoming more and more important, in fact, like crucial tool in forestry research, both on the research side as well as on the management side. And the important part is that they really provide an opportunity to collect high resolution data at different spatial and temporal scales. They also enable to do repeat monitoring, which is really important. So that's something that is not as easy if we consider more traditional survey methods. And, so they allow us, for example, to do assessment across seasons, productivity assessments. And also, very importantly, they bridge the gap between ground-based surveys and satellite data. So in forestry research, we've been using satellite data for a longer time before the drone, let's say. Satellite data are still very, very important tools, but they play a different role. They provide coarser spatial and temporal resolution, but very important for bigger areas, for the landscape levels. On the other side, we had ground surveys, which are the traditional way we investigate our plantations. But those are, we know, very time-consuming, expensive, and also more subjective in the sense that the team that goes out to do the assessment, there is also always a level of inconsistencies and a bit of a bias. So that's where the drone fit in. They provide that very high resolution, high temporal resolution and spatial resolution tools for monitoring and managing plantation forests. And therefore, they definitely play a crucial role in precision forestry. So, we speak about drones, but drones are actually just carriers of tools. So they are what we use to carry the tools that we want to use to collect data. So just very briefly, an overview of the main tools that we have that we use in collecting data in plantation forestry. Firstly, the RGB, those are the normal cameras, the ones that we use that on the phone, the one that we use normally. They basically cover the visual, in terms of the spectrum, they cover the visual part, so the part that we can see with our eyes. Those are relatively inexpensive. They have a very high spatial resolution. They're excellent for photogrammetry. So when you want to take metrics in terms of data collection, for example, trees and seedling count, canopy gap mapping, crown geometry with some limitations. Then we have the multispectral. The multispectral are more, they cover the near infrared and red edge, which are outside our visual spectral area. And they are very sensitive to the chemical components of plants. So very sensitive to chlorophyll, for example, concentration, important in terms of collecting data about the phenology of the trees, about stress. So those are the sensors that we mainly use when we look at forest health. We want to monitor leaf area, above ground biomass, and so forth. And generally, that we use the spectral reflectance to develop specific indices that are very useful for monitoring these characteristics. So they have fewer bands, not as sensitive as the hyperspectral, but still, extremely useful, particularly when we look at stand level assessments. And then we have the hyperspectral sensors, which are, they have thousands of bands arranged in a very narrow bandwidth. So we have many, many more readings for the same part of the spectral readings. And so those provide much more defined and detailed information. And they're very important, again, for chemistry, for foliar chemistry and subtle physiological changes, but they have very heavy data requirements. So, the one message that I have throughout my presentation is that the most defined sensor is not necessarily the best for the study because of the data requirement that comes with that. Then we have LiDAR. LiDAR also can be attached to drones, and they're very important in terms of three-dimensional forest structure. So they based on like radar-like of sensors, so they don't really take reading in terms of the reflectance of the objects that we're interested in, but they do take the structural picture of the object that we are examining. So they're very important in terms of individual tree metrics, fuel load, crown structure mapping, and changes of those. The cost of the sensors are limitation, as well as the payload. Those are quite heavy equipments, and again, heavy data requirements in terms of both pre-processing, computational, and storage. And then we have other tools that, in fact, are very, I would be very keen to test myself. We don't have the opportunity yet. That are, for example, tools that one can attach to the drone to take actual physical samples of the canopy, for example, like branch and leaf samplers, or pollen, seed, and fruit collections using adhesive traps, and also for the placement of microclimate data loggers on the canopy if we want to have do a study in terms of the microclimate within the canopy. So there are infinite ways to use the drone that, as I say, is just a carrier that can go in places where we cannot really go easily physically. So the questions that comes is which sensors for what? So it's, as I mentioned just now, the most sophisticated sensor is not necessarily the best that you can have. And that's something that is very important and that we've learned at the ICFR through the experience that we had in the last 2-3 years, in terms of this type of work that we've been doing. So the first thing is your research question. So the sensor choice must be driven by the target metric rather than the sensor novelty. So we may be instinctively prone to look for the best sensor that we can buy, but that's not necessarily the best for what we need. So what we need to consider when we want to do research using one of these tools is the spatial resolution that we have. So required ground sampling distance. Do we want to collect data at tree level, so centimeter type of spatial resolution, or standard landscape level, so going up to a meter resolution? Also, taking into consideration the spectral resolution and bands based on the traits of interest. So, for example, if we're interested in a study that requires readings of chlorophyll, we need to include the bands red edge and near infrared. If we're interested in more like moisture and water, we need to make sure that our sensor collects data around the infrared area. Another important aspect is the payload constraints, so the sensor weight. So we can buy a very expensive sensor that will do wonderful things, but our drone, our carrier, is not strong enough, is not big enough to carry that sensor. So also the bigger the sensor, the flight time is also reduced because of the higher consumption. So that's also another thing that is important to keep into consideration. And that's something that all of us, that we've been working together in this area of research, the data volume and processing. So we can collect wonderful data, extremely detailed data, but we're collecting a huge amount of data that requires huge storage space and huge computational and processing capacity. So we need to also consider, when we choose the selection of this of the sensor, research question, as well as what do we have in terms of infrastructure to store and manipulate that data. So it really comes down to a cost-benefit analysis and trade-offs, which is really important. And it's actually a recurrent theme also in literature. So collecting data is just the start. So, it's one go out with a drone, camera, collect the data, but then the work starts when you go back to the office and you have to do the image processing, data extractions. So in terms also of the capacity and capabilities that you require in a project that make use of this type of tools, is to have the infrastructure in terms of data storage and processing, as well as expertise in-house in terms of AI and machine learning capacity, because the data processing and interpretation of this data requires quite high levels of this type of skills as well. So to go from an image like that, like a picture, to something that you can interpret from, for your research project, requires a level of expertise that is not just going out and collect the data and then the image will tell us. So as I said, I'm talking from like a direct experience perspective, because about 2.5 years ago, ICFR, FABI, and Stellenbosch universities were given a grant, which we're really grateful for, from FSA and Department of Science and Innovation, to really start developing a platform in support of the forestry industry in South Africa, to really develop and consolidate knowledge and methodologies across the forestry sector to promote the use of special technologies and remote sense data for sustainable forest management. So we developed our work plan, our area of focus area in terms of our research, where FABI and ICFR were more closely working closely together in terms of forest health monitoring, and Stellenbosch universities focus more on the forest management aspect under the leadership of Professor Bruce Talbot, with FABI working with, of course, Professor Bernard Slippers. So with regard to FABI, their focus is on the development of a pest and disease spectral library, so trying to develop spectral signatures that are pest or pathogen specific, so that we can facilitate the monitoring and detection of pest and pathogens using these tools. And on the ICFR side, we are starting to develop a spectral library of forestry species and hybrids and across seasons and crop stages. So those two, the focus of FABI ICFR is to develop the tools that we need to develop a change detection system that can pick up early enough the incidence of pest and pathogens across the landscape, using several remote sensing based tools from satellite imagery to drone, as well as, of course, ground surveys. So FABI ICFR, as I said, we're developing remote sensing based technologies for monitoring forest health. The focus at the moment is on exploring how we can utilize unmanned area vehicles to support this research area. So we decided to purchase the same equipment. We have a DJ 300 and 350 with, FABI and ICFR, the same camera, MicaSense 10 band dual spectral multispectral camera, which is a really good camera. We have 3 pilots at the ICFR that were licensed, and Greg will speak later in this and will give you his perspective on how difficult was the whole process of going through the drone registration, the ROC, and all that comes with that. So acquiring the equipment was quite a lot of work in itself. So the key aspects of these platforms are really about resource optimization and interinstitutional collaboration. So you can see here that we've been working together a lot in field and also in the office. You see the team of students from Stellenbosch joined us. You see here us in field, testing the drone, and Greg in action there. So it really tried to create a shared expertise and skills across the institutions. Capacity development also a crucial part, because as I said, having the equipment is just the beginning. it requires a lot of skills and expertise. So we started with a postdoc at ICFR in Tembeni Ngadi, which he was with us for 1 year, and he's still collaborating with us after taking his position as a lecturer at UKZN. He's still involved in our research as a supervisor of Wandile Kumalo, who is the MSc student on the project, and who is working on enhancing eucalypt hybrid clone discrimination through multitemporal UAV imagery across developmental stages, crop stages. And now we also have Kelukolo Dlamini, who is a remote sensing research assistant at the ICFR. He's very skilled in the use of drone for his PhD. He's also using drone for data collection, and he's assisting on the project as well. So we also have a strong focus on standardized methodologies and data management, because as I mentioned earlier, collecting the data in field, firstly, the equipment is very expensive. Then collecting data in field is also very expensive. And the old data, image processing and storage, it's also very expensive. So we decided that we need to make the data that we collect for a specific project available for the platform, for whoever needs that type of imagery for other projects or future projects. So in order to be able to do that, it requires a lot of discipline in terms of how the data is collected and how the data is processed and stored, and the collection of metadata. So the idea is to develop, and we are working on that. In fact, it's actually been developed. We're just testing it and starting to populate an image repository on the information hub at the University of Pretoria. We have developed a flight logbook with an app that can be, used in field directly by the pilot, and also a standardized metadata sheet for data collections. So the effort is really in terms of focus on standardizing methodologies for this searchable image library. And for this, we also relied a lot on the expertise of Professor Bote Maas from Ghent University, who you can see in the picture, visited the ICFR and is a very close collaborator of Fabi, and really helped us getting this, develop these baseline methodologies for good, correct and clean data collection and metadata recording. So a little bit specifically on the research project that we're busy with our MSc student Wandile. She's a MSc student at UKZN, and her project has been strongly supported by SAPI, who allowed us to work in field, provided advice. Kabir and Jakob provide a lot of advice in terms of the data collection based on their expertise and previous experience. And so we're very thankful for SAPI supporting this project. So Wandile's focus in looking at the utility of the drone collected imagery using our microsense sensor in discriminating between specifically Eucalyptus grandis and Eucalyptus grandis europhylla in winter and summer, so including a seasonal variation. So specific focus is on the hybrid species. We're using our microsense 10-band dual camera, and the stands that we selected were post-canopy closure. We did summer and winter flights, and her focus is on spectral discrimination and seasonal reflectance variation. So just a little bit on where she is now with her project. She's completed the data extraction and the model for the summer season using zonal statistics and about 150 trees per sample area. She used as a model random forest, and the test data set was spatially independent from the training data set. So we're trying to have a model that is generalizable. We don't want a model that just works specifically on clan and on the farm where we collected the data, which is one of the risks of those remote sensing based models. But we really strive for generalizability. And for now, the species discrimination has been done on summer data only, achieving very good results with the overall accuracy of about 93%. And those are the maps that she's developed. Danya is our pure species control. And yeah, so she's basically focused on Shafton and Clan, developing training on one farm and testing on the other farm. In terms of seasonal reflectance variation, the project is still, she's still busy with the analysis. But as I said, the priority is no regional or temporal specificity of the model, because this is one of the requirements of the spectral library, which we said we want to develop the spectral library so that we can use it over the landscape for picking up anomalies in terms of reflectance, species reflectance. So we need to have a general model. So the model is developed following the LORO and LOSO principle, which has leave out one region and leave out one season in terms of testing. So you developed leaving out one season and test on the season that was left out, or leaving out one region and testing on the region which was left out, which ensure the generalizability of the model. So just to conclude some takeaway points. So yeah, drones have become and are becoming more and more an essential tools in advancing forestry research through high resolution, repeatable and effective data acquisition. And the integration of drone collected data with ground-based and satellite observations offer really new opportunities for multi-scale, multi-temporal analysis and improved decision-making. We're very proud of the fact that our three institutions, FABI, Stellenbosch, and ICFR, have embraced this opportunity of working together and develop a platform to advance remote sensing for forest management. And we really hope that this initiative goes beyond the SIF funding, which are due to finish by, the grant runs until mid-2026. The one message that I found really important is that data collection and storage are costly, as well as data processing. So in matching the data collection strategy with the objectives is very important. Following protocols and record metadata is also very important, so that that image can be used for other multiple projects, and also collaborating for efficiency, effectiveness, and shared learning resources. It's key. Thank you for the opportunity to give this presentation, and please feel free to drop me any questions if you have any.